In level 4, we're going to explore what another part or another change to our graph can do to the shape or to what the graph looks like. So when we look at y equals negative x squared, we can take and plug each of those values of our table in for x and see what happens. So we have negative from the outside of the x, and then we have to put our -2 inside parentheses before we square it. The negative from outside the x, put the -1 inside the parentheses before you square it. Negative from outside the x, then our 0 squared, all the way down. So we'll type that into our calculator. And we have negative, parentheses, -2 squared. Change your -2 to a -1. And remember, I don't need that extra spot there, so I'll just delete it, and I get 0. Change your 0 to 1, -1, and finally change your 1 to a 2. And we get -4. Let's go ahead and plot these points and see what happens to the shape of our graph. -2, -4, -1, -1, 0, 0, 1, -1, and 2, -4. When I look at this graph now, we're seeing for the first time what happens to make it open down. We finally have our vertex acting as a maximum. So what happened was our graph went from opening up to opening down. And what caused that equation to change? How does this graph differ from the parent equation or from the parent function? Well, the only thing that changed was your a became negative. That is why when we talk about a being between 0 and 1, why we don't just say when a is less than 1. Because when a goes into that negative territory, it has no bearing really on the width of the graph, but the negative just makes it flip upside down. So let's kind of put it all together and put two transformations into our parabola. Or actually, we're going to have three transformations. Break them down real quick. This negative, as we just discovered, means that it's going to open down. Means it's going to have a maximum value. This 1/3 is between 0 and 1. So that means that it's going to be a wider graph. And then this 2, since it's up or +2, it means it's going to move up 2. So when you make these predictions, you can already build into your brain what this graph should look like. So if you get something that's completely different than what this is showing, then we know that we need to go back to the drawing board and reevaluate because we've made a mistake somewhere. Pay close attention to the x values that I chose. I had a fraction for my a value, so I looked at the denominator and said, oh my goodness, I need to pick things that can be divided by 3 to avoid any fractions. So 0 didn't matter, but 3 can be divided by 3, so can -3. 6 can be divided by 3, so can -6. So now I have numbers that can be divided by 3 as my x values. We'll go ahead and plug them in. -1/3 times -6 squared plus 2. And of course, we're going to make sure that we put our numbers in parentheses before we square them. Should have made my table just a little bit bigger. When I plug it in, we'll have negative, there's our fraction, 1/3 times negative 6 squared plus 2. Putting it all in one single line. And I get negative 10. This is definitely one that I probably want to practice my copy and paste skills on because it's a little bit more intense to type. I get negative 1. Now when I transition to 0, I no longer need 2 spots inside the parentheses. So I'm going to delete 1 and change it to 0. Change 0 to 1. And we get, whoopsie, I didn't mean to change it to 1. I meant to change it to 3. But there's a great example as to why I choose numbers that can be divided by 3. Because when I had a number here that wasn't divisible by 3, I ended up with a fraction I'd have to graph. There's our 3. Change your 3 to 6. Now we can go ahead and graph. Negative 6, we go to negative 10. Negative 3, negative 3. 0 goes to 2. 3, negative 3, and 6 to negative 10. Nice rounded shape for my parabola. And there we go.